Hi, in this video we will learn about vertical asymptotes. Let me just write down the definition. The asymptotes, vertical or horizontal, these are straight lines. Vertical means that we are dealing with a vertical straight line. So in the equation for vertical asymptotes will be x equal to some constant. So a line x equal to a is a vertical asymptote of function f if the function has infinite limit as x goes to a plus or x goes to a minus. In other words, when you find the limit of x goes to a of f of x, from the right or left you get plus infinity or minus infinity, or as x goes to a. Any of these happens, you say that x equal to a is a vertical asymptote for the function f. Well, it's very important to see how does this work for the graphs. So graphs, for that, let me just paste this thing. Okay, so this will have different forms, but here I will just show you some of it. So as x goes to a, it can go up like this. This means that limit of f of x as x goes to a plus is plus infinity, and the minus side can be also something like that. It gets closer and closer to this line. It never touches that. Or it can be both here going up and like that. They never touch. Some can be like both going down and something like that, or this guy goes down and this guy goes to positive infinity. It never touches, but it gets closer and closer to x equal to a. There is a very important difference between a vertical and horizontal asymptote. Unlike the horizontal asymptote, which function can have only one or two, maximum two horizontal asymptote, vertical asymptote function can have as many as you like. So we may have functions can have any number of vertical asymptotes. The reason I am writing this, just compare this thing to the case where we have a horizontal. At max, we can have two horizontal, but for vertical, we can have as many as you like. Let's just do one example. Find horizontal or vertical, sorry, vertical asymptotes of the function f of x equals to x minus 3 over x plus 2. Okay, where should we start? We are looking for points at which at which function has infinite limit. What you should remember from infinite limit from the previous video is that infinite limit happens when the limit of the denominator is 0. So note that infinite limit happens at points where the denominator has limit 0. But the denominator is x plus 2. It has limit 0 if and only if the function is 0 at that point. So we set the denominator 0, and from there we find that x equal to -2 is a candidate for vertical asymptote. Then we check that as x goes to -2 of the numerator, this is -2 minus 3 is -5. It is non-zero. And limit of x goes to -2 of x plus 2 is 0. Non-zero numerator limit, 0 denominator limit. Right away, that means that f has infinite limit at x equal to -2. Well, that means that x equal to -2 is a vertical asymptote for f. Well, you can do a little bit more details. As you remember, x minus 3 over x minus plus 2, as x goes to -2 from the left, this will be -5 over 0, negative, minus sign, this will be plus infinity, and limit of x minus 3 over x plus 2 as x goes to -2 from the positive side, this is -5 over 0 plus, and negative time minus negative times plus sign, this is negative infinity. This last piece we just find it for ourselves, but just knowing that we have infinite limit at x equal to -2 will give us the vertical asymptote. Well, doing this example give us some idea of how to find vertical asymptotes. So let us just write the steps here we want to learn. So how to find vertical asymptotes of a rational function. This is in general for any fractional function and any quotient function you can do this, but we will just restrict ourselves to the rational function. So let f of x is px over qx. Well, the first thing is first, find all the zeros of the denominator. So in other words, solve qx equal to 0. Why? These are the points at which the denominator has 0 limit. Well, that means that we can start with these points and find all of its roots, all of its 0. These are candidates for vertical asymptote. but we have to make sure that they are. Then for each one of the roots, for each one of the roots found in the previous step, check if the function, if f has infinite limit. If it has infinite limit, that will give you a vertical. If doesn't have, it won't be a vertical asymptote. Well, let's just do some example here. Example. Find vertical asymptotes of given functions. Okay, so the first function is f of x is x squared minus 1 and x squared minus 3x plus 2. The second function is f of x equals to x plus 3 x squared plus 2x minus 1. And let's do just these two. Okay, so what should we do? So the first step is find what points make the denominator plus 2 equal to 0. So here, so we are trying to find two numbers which add up to -3, and when you multiply you get 2. That's -1 and 2. So we have two roots, x equal to 1 and x equal to 2. We have to check both of them if the function has infinite limit in both of them or not. So for x equal to 1, we have to find limit of x squared minus 1 over x squared minus 3x plus 2 as x goes to 1. Well, you can do left or right, but what is important here is that you see that if I plug in the numerator 1, it will be 0, the denominator is 0. Well, 0 over 0, you remember this is indeterminate form, and to be able to find the limit, we need to factor both numerator and denominator and cancel out the vanishing factors. Here is this. The vanishing factors are x minus 1, x minus 1. So we find it and we get, well, this is limit of x plus 1 over x minus 2 as x goes to 1, and that is 2 over -1, and this is -2. This is not an infinite limit. What does it mean? It means that x equal to 1 is not a vertical asymptote. That's the first thing. Then the second thing, there was another point, x equal to 2. So we have limit of x goes to 1, x squared minus 1 over x squared minus 3x plus 2. And this gives us, sorry, as x goes to 2. This is 4 minus 1 is 3 over 0. As you know, if the limit of numerator is non-zero, limit of the denominator is 0, this is an infinite limit. Well, you can study in detail when it is positive infinity or negative infinity, but for vertical asymptote, this is enough. That right away means that x equal to 2 is a vertical asymptote. And as a result, f has only one vertical asymptote. X equal to 2. The denominator had two roots, but here now we have only one vertical asymptote. One of them were only vertical asymptote. Let's do the other one. Well, set the denominator equals to 0. That means, oh, what is this? Sorry, this was supposed to be x squared plus 2x plus 1. And that means that we have x squared plus 1 squared equals to 0. That means that x equal to -1 is the only root for the denominator. So then we need to find the limit of f of x as x goes to -1. This is limit of x plus 3 over x, well, I can write x plus 1 squared as x goes to -1. And as you can see, the numerator will be 2 and the denominator will be 0. And remember, x plus 1 to the power 2 is always going to be 0 plus, so this will be positive infinity, and that means that x equal to -1 is the only vertical asymptote of f. Okay, so we started with the definition, uh, what is a vertical asymptote, and then we saw what does it mean in terms of graph and how we can find those points. Remember, in the denominator you should get 0, but then you have to check that the limit of the function at the zeros of the denominator are giving you infinite limit. And that's it.